Hello. My name is Akash Kumar and I'm a software engineer here at Hubmaker Labs, your one-stop shop for all things Web3 social media. You may know us from Catalyze.1, our premier Web3 Discord alternative, built upon the Internet Computer Protocol. Well, today, I'm here to present you our newest project, Replicator. Replicator is a nostr relay with Internet Computer integration for inter-relay synchronization. To understand Replicator and its importance, let's first take a look at nostr and what role relays play within nostr. So nostr is a decentralized protocol that offers a flexible architecture for building a variety of social applications. At its core, it operates on a user relay model where users generate content using cryptographic keys to ensure authenticity, and then publish these messages through a network of relays. These relays, which anyone can host, serve as neutral conduits that transmit data without controlling it. This structure not only supports the usual social media interactions like posting and messaging, but also allows for innovative applications such as encrypted communications and financial transactions. The user relay model underpins Nostr's adaptability, enabling a diverse ecosystem where developers can create tailored experiences without the constraints of a centralized platform. In addition to its many strengths, Nostr does also have some limitations. Now, to understand why Replicator is so important, let's understand the limitations of Nostr in its current state. Here we can see a classic problem that Nostr faces: data inconsistencies. So when user A saves a post to relay A, the only way that user B can see that post is if they're subscribed to relay A. In the case, as is in the last image, or the last panel of this image, when user A and user B are subscribed to two separate relays, there is no way for either of the users to see each other's posts. Now this has a couple of implications. Firstly, this means that the network is very fragmented, which means it lacks the C consistency in the CAP theorem, which defines a robust network. Additionally, this leads to bottlenecks. Nostr's demand-driven approach can overload specific relays serving popular content, impacting performance and potentially leading to additional failures across the network. Now, some relays that currently exist have solved this issue via set reconciliation, as is the case with the popular relay stir-fry, which uses negentropy. Now, the issue with negentropy is that it very randomly and arbitrarily spams the surrounding negentropy nodes in the network with requests to synchronize until eventually the whole network is synchronized. This can be very slow, resource-intensive, and unreliable, leading to data inconsistencies, gaps, and longer delays to the replication of the most frequently requested data. Now, the way that Replicator solves this issue of data inconsistency within Nostr is via a replicator canister on the internet computer, which is used to synchronize a replicator relay cluster. Now, a replicator relay cluster is a cluster of relays, specifically replicator relays, that are authorized to access the replicator canister and use the canister for synchronization purposes. Now, the canister stores all the Nostr posts within the relay cluster. It stores each post with the event ID as the primary key. Now, because the canister stores all events, the relays can then afford to not have to store all the events, and therefore we have these two icons that can be seen on each Nostr relay. It's a database symbol with a lightning bolt, which represents a cache, and a magnifying glass. So each replicator relay has a highly robust garbage collection system that systematically deletes posts that are infrequently accessed while still keeping the metadata for that post. On the other hand, we have a magnifying glass, which represents a highly robust indexing mechanism within the replicator relay database to ensure very efficient and speedy queries. So, bringing all this together, a query is sent to a replicator relay. The replicator relay very quickly organizes and determines which event IDs correspond to that query. Now, it might not have all the content corresponding to that query, but if it can send the event IDs to the canister will then serve up the content corresponding to those event IDs. And because the event ID is used as the primary key in the canister, this query to the canister is also very speedy and efficient. Therefore, we can say that the relay essentially acts as a cache and a search engine, while the canister acts as the event store and tool for synchronization. Now, let's see this in action. Now, in front of us, we have 4 different panels in 4 different corners. On the left side, we have 2 terminals that are each running a separate instance of the replicator relay. Now, both of these replicator relays are a part of the same replicator relay cluster, such that both are using the same replicator canister on the back end to synchronize. Now, because the bottom client is connected to the bottom relay only, and the top client is only connected to the top relay, they should not be able to see each other's posts. But the bottom user posts, and almost immediately the top user is able to see it. This not only works with posts, but you can see he heart reacted it, and now the bottom user sees the heart reaction. This not only works with reactions, but DMs as well. As we can see here, the top user DMs testing to the bottom user checks his messages, and almost immediately the encrypted message is able to be seen. Thank you for watching. We hope you enjoyed, and a big thank you to all of our supporters.